Hello everybody. Alright, believe it or not, this is the night before, not the morning of, which is crazy. Alright, let's get this started. So, some of you are in class today taking the benchmark, and if that's the case, you don't have any homework tonight. And some of you haven't taken the benchmark yet, which means that you're watching this on Monday. And some of you took the benchmark on Monday, and then you'll watch the Friday video today on Monday, and then Tuesday you'll watch this video. So you're either going to watch this Monday or Tuesday. And this homework, with the homework that was given in the previous lesson, is due on Wednesday. So today we're doing the second half of our 5. It's all about adding and subtracting rational expressions. Okay, so we're only going to do 3 examples today, and you can get going on your homework right away, so it shouldn't take too long. Okay, so let's say that we were adding 5 over 9x squared plus 6x. Well, this is just like when you're adding fractions, just regular old fractions. So you got to find a common denominator. You do not need to find a common denominator when you're multiplying and dividing, as you found out in the previous lesson. Right now, we just need to find a common denominator for these. So the question is, what does 9x squared and 6x both go into? Well, 9 and 6 both go into 18. And let's see, we need something that x squared and x both go into, so x squared should cover both of those. And just like adding fractions, 9x squared times 2 makes 18x squared, and 5 times 2 makes 10. All right, here we've got 6x. We're trying to get to 18x squared, so we're going to multiply by 3x. Gets you 18x squared, so we're going to multiply the top by 3x too. And then your final answer is just putting it together with only one thing on the bottom. I've been asked a lot why there's only just 18x squared on the bottom. Not in this particular circumstance, but in other ones. So, and why it's not like 2 of those, why you wouldn't take 18 times 18 or something like that. It's just like if you had like 1/4 plus 2/4. That would equal 3/4. You wouldn't say it's 8 on the bottom or 16 or anything like that, so that's why. It's just like what you're used to with adding fractions. All right, here's the second one. We're only doing 3, but number 3 is a doozy. So, they almost have the same denominators. The problem is that this one, the y, is positive and the negative, or the 2 is negative, and here the 2 is positive and the y is negative. So, if I multiply this one by -1 and the top by -1, I should get the same denominator for both. So this one just stays the same. And this one becomes -8. And it makes sense because -1 times -y is positive y, and -1 times 2 is -2. So our final answer is y minus 8 over y minus 2. And you can't cancel out the y's on the top and the bottom because just like last time, they're kind of like stuck together with that minus sign. So that y minus 8 can only be canceled out with another y minus 8. Okay. Example 3. This one's going to be a little gross. All right. Remember, you can stop anytime you want to. Pause, catch up on the notes. Okay, so if you have things that just aren't in common on the bottom, just as if you had, like, I don't know, 1/3 times or plus 1/2. The common denominator for this one, since 3 and 2 don't have anything in common, would just be multiplying them, so 6 would be the common denominator for this situation. What we're going to do to find a common denominator is just use every single one of these, the x minus 1, the x plus 2, the x plus 3, and the x minus 4, which is why this is going to turn into a very gross, big problem. So let's see, the object is getting all of them on the bottom. Okay. Now, what did we need to make that happen on this one? Well, we already had the x minus 1 and the x plus 2, but we had to multiply in that x plus 3 and x minus 4. So I'm actually going to write that right here. And on this one, we had the x plus 3 and the x minus 4, but we didn't have the x minus 1 and x plus 2. In these types of problems, it's generally accepted that it's okay to leave the bottom in all those parentheses, but it's not okay to leave the top in all of those parentheses. So we're going to have to multiply it out to figure out what it is. So for this one, we're going to take 3 times x plus 3 times x minus 4. So on the bottom here, I'm going to do 2 quick Punnett squares. So the first one is x plus 3 and x minus 4. And the second one is x minus 1 and x plus 2. You guys are pretty good at this point. So I know that I'm going really fast. So you should probably pause the video right now and make sure that you are on the same page as me. So do it yourself. Don't just copy it down. Okay, so I'm going to take those numbers and I'm going to put them in up here. So this one is 3 times my result from the first Punnett square, which was x squared minus x minus 12. And this one is x squared plus x minus 2. Okay. But this minus, I don't like that because I'm going to have to subtract all of these and I'm always going to forget. So instead, I'm just going to distribute a -1 to all of them. So my next line, I'm going to combine them together with this on the bottom. But in the same move, I'm also going to distribute stuff. So it's going to get a little complicated, but I'm putting them together now. So let's see, I'm going to distribute the 3 to each one of them. So that's 3x squared minus 3x minus 36. And then here I've got to distribute that -1 to each one of them. That's -x squared, -x, and +2. And then for my final answer, I'm just going to combine like terms. Let's see, 3, I'm going to scoot over. So 3x squared minus 1x squared is 2x squared. And -3x minus 1x is -4x. And then -36 plus 2 is -34. That's the answer. That one, P.S., is harder than any problem in your homework, but it will get you prepared for the problems in your homework that you still have to do. So I gave you page 53, last lesson, and this is page 54. It is numbers 52 through 64 evens, and then number 69. Now, number 69, besides being a hilarious number. You have to factor the bottoms first. And that will give you the factors you need to do something like this. Of course, if you have any factors in common, you don't have to multiply those times each other. You can just use those once.